Welcome everybody to show number, are we on 12 or is this 13, Dan?
We're actually 12.
12, show number 12. And if you caught the theme entry music, a little under pressure, because today we are going to be discussing using pressure with a base station 3200 controller and some of the things you can do to manage your system using pressure. And just a reminder for everyone that this could be your first time joining us, that all the previous episodes have been recorded and are on the Baseline web training YouTube page. So to find that, go to YouTube, search for Baseline web training, and you'll find all the previous episodes of Baseline Tech Talk Tuesday. And again, for some quick intros, I'm Andy Humphrey, Regional Sales Manager in the Northeast. We have Dan Conger, our National Training Manager, and Chris Wright, our VP of Sales. And I think, Dan, if without further ado, let's hand it over to you.
Awesome. So today we're going to be talking about, as you mentioned, managing with pressure on a base station 3200. So I always like to start off with why are we even talking about this? So I've been in the industry a little over 30 years, and flow data has always been around during that time that I've been in the industry. And it's proven really valuable. And we know that flow and pressure are related, but they're different. They are not the same thing. We have seen systems where we have too low a pressure, right? And then we get poor coverage and poor DU. We see that pretty commonly. But we see the inverse too, right? We have excess pressure, and that causes misting and drift, and that gives us bad coverage and poor DU as well. So either end of the spectrum, we've got issues. We also know that a change of 10% in 10 PSI change is going to give us up to a 40% increase in water use or water consumption. So we're seeing this connection between those two. So if we can better manage our system pressure, we can better manage our resources, our water on our systems. Mm-hmm. I think the other thing about this is that pressure is another data point that we can use to make better management decisions on our irrigation. So the more we know, better off.
Very helpful for diagnostics too. So I don't remember if we got into that, but if there's something that wasn't working correctly, let's say yesterday, flow-wise, it's a great data point to be able to reference to make a correlation to what could have been happening.
Right on. Yes. Well, I'm going to share my screen and show you what I've got a few things to show you. Tools that we're talking about. The first one we're going to talk about is actually what we call a control point, and a control point is a conglomeration. There's multiple things that we brought together. So a control point has a flow sensor built into it. It has a master valve bicoder built into it. You're going to need to add your own master valve, and it has a pressure transducer and a pressure bicoder all built into it. So what's nice about a control point, right, is we have multiple data points, and we have an ability to control flow with a master valve. So all those things put together. But really, we're concerned about the pressure. So we could also look at pressure as just the pressure sensing kit. So down on the bottom, I've got a pressure sensing kit that has a pressure transducer and a pressure bicoder. Comes from us just that way. But Andy, you had a project that you were using a different pressure transducer, one that we don't initially have as a part number, and you connected it with their bicoder. So you had those different options there.
And we'll jump into this at the end. So we have the kit that Dan mentioned. It's right there with the decoder and the pressure transducer. The decoder is sold also individually, so you can connect it to any 4 to 20 milliamp pressure transducer of your choice, and they come in lots of different ranges from a 0 to 10 PSI transducer to a 50 to 150 pressure range. So any pressure transducer that's 4 to 20 milliamp can be connected right into our decoder.
Yeah, so lots of options on that. So I think I want to reiterate where we can do this. So on traditional systems, and what we're always used to, especially people like me that have been in the industry for a while, we're used to our master valve and flow sensor being back at the beginning of the system. Well, control points don't have to go there, right? They can go anywhere on the main line. So they can go in multiple locations And a single base station 3200 can handle 8 different control points. So that would be 8 pressure sensors, pressure transducers, 8 master valves, 8 flow sensors that could be spread around the system as needed. So the flexibility on where this goes can become really valuable as you get into the more advanced settings. And when we get to your last case study, that really illustrates that putting that in a different location. So here's some of the actions, some of the things we can do with pressure data, right? We can report, so we could collect real-time pressure data and then just review it when it's convenient for us. We could set it for alerts. So I could, if the pressure drops below 25 PSI, say, I can have it send an alert to me on my mobile or to my office. We could use it to start. So allow the system to start irrigating when the pump reaches 80 PSI. We could use it to stop irrigation. So stop irrigating and close the master valve if the pressure goes above 150 PSI. We could use it to pause a system. So when the pressure drops below 25 PSI, it's going to pause, and then it'll begin later on when the pressure comes back up. We could also use it to delay the opening of one of the next zone in a program until the pressure comes back up to 40 PSI. Right? So we can have lots of choices, lots of things we can do with them. But we can take these actions at both the mainline level and at the control point level. So it's not just at one particular level. So pressure damage is something that we could use pressure components to address. So water hammer damages fittings, it breaks pipes. And if it's bad in a 2-inch pipe, it's going to be catastrophic when we get to a 6-inch pipe. It's just, you think about the hole that's going to create if we have a broken 6-inch pipe. So surges or spikes in water pressure is going to make that water hammer even worse. So here's 2 ways that we could address pressure issues using a pressure component. When the pressure is higher than 125 PSI, we could close the master valve and isolate everything downstream so we prevent any damage. That was one way to tackle it. Another way to tackle it is when the pressure is higher than 125 PSI, that same level, we could start program 1, and maybe program 1 has 4 rotor zones, and it's going to actually relieve pressure. So 2 ways to solve that problem. One is just closing the master valve, and the other is starting another program. That's
And again, you mentioned 125 PSI, but the pressure be whatever you want that high pressure activation to be. It could be 60, it could be 200. It's user definable.
Absolutely. I think that's important. Yeah. So pumps. So new pump stations like this one, they have sophisticated controls, right? But old pump systems don't. Sometimes they're just off and on. And it would be great to buy, enormous, beautiful pump packages like this one, but that's just not. Sometimes we just have old stuff that we're dealing with, and that's what we have. And on those old systems, it's really easy to deadhead a pump. So pump against a closed gate valve. And this is something that is very real. I picked this up when I worked distribution. This is an 1.25-inch pipe, and they were pumping against a closed gate valve right after that union. They pumped against it all night, and that 1.25-inch pipe swelled is the right word, swelled up to at least 3 inches, and it's paper thin. And I really got to credit the person that went to shut this off, because that was incredibly brave, right? That was ready to burst. Well, how do we get those pump controls on our simple pump system? Well, we can do that, right, with our pressure component, right? We can do a start, stop, or pause condition and control a pump based off of allow a pump to start if the pressure is at a certain level, or stop it or pause the pump if the pressure is at a certain level. So we can get some very similar pump controls out of that sophisticated pump package on our old pump system. I think we mentioned the other day, for a relatively modest fee, you can add just the pressure component, and you can upgrade your old pump the computing power is already there in the base station 3200. So we're just going to add the pressure input, and now we could prevent this from happening. Now, scale that up from 1.25 inches to a 4-inch or 6-inch. That's pretty serious.
And you actually have that, right, Dan? That balloon pipe.
It's
there it is.
And it's nice and thin. It's what's funny is this tells you the irrigation nerd that I am. When I asked the guy, I said, "Are you going to throw that away? Could I have that?" He said, "Yeah, sure." I'm like, "Oh, this is the greatest thing ever."
Looks like it'd make a good juggling stick. You know, it's like a bowling
pin.
Kind of
looks like
a couple of them.
A bowling pin or something like that. Well, there's what time, pressure, heat are 3 things that you can use to mold plastic, and this had 2, if not 3 of those things. It had time and it had the pressure. Let's look at flushing filters. So irrigation filters need periodic flushing to clear out that debris that's going to collect in there, especially if we're coming from a well. It's going to have more sand and grit. So manual flushes and time flushes are options, but they're not based on actual needs because it's just purely a timer, right? Well, what can happen there is the controller doesn't know when those flushes are happening because it happens when the timer says, right? If it's connected to an old Intermatic timer or something less sophisticated, it's just going to click on and click off. Well, what can happen is you can create an issue by your own doing of flushing the filters at the same time as you're running irrigation. So what happened now is we've dropped our pressure because we're flushing it off and reopening it back at the beginning of their system, and now we have poor coverage, poor DU on the rest of our system because we've released all this pressure. So how about we use a transducer, and we set up a filter flush based on a pressure. So when the pressure reaches a certain point, it's going to automatically flush the filter. And since it's on the same system, we're going to pause our irrigation. So now our irrigation is paused for the 5, 10, 30 minutes, however long it takes to flush the one filter or the 5 filters that we might have, and then resume irrigation once the pressure's back up to its correct point.
Yeah. And Dan, there's a couple things that stand out here. Number one is that when you add automatic backflush to a filter system or a pump system, there's immediate costs that comes along with that. So I've heard recently anywhere from $1,500 to $3,000 for auto backflush. And, essentially that capability is built into the base station 3200. You just need the pressure transducers to read it. So you have that control out of the box with the irrigation control system. And then, as you mentioned, because the base station 3200 is also managing the irrigation valves on site, if they weren't managing the backflush, the water source would essentially shut down in order to backflush the filter. Meanwhile, the irrigation valves are running, and the controller could potentially have a low flow alarm because the water source basically turned off while the irrigation was running. Okay. So it is becoming more important to have one brain on the site controlling all of the water and filter flush cycles like this, so it can operate correctly without sounding false alarms.
Another alternative would be to set up a dedicated time when no irrigation's running, but that assumes you've got all the time in the world to water your site. And we talked about challenging water windows last week, and this fits right into that one. If you have a challenging water window, we need to compress all that down. We don't have time to spare. And I really like that idea of a single system to control anything related to water or irrigation. Okay, now we're getting into some real, this is not 101, this is 300 and 400 level irrigation here. So we're gonna look at tank levels, and we've talked about the idea of using a soil moisture sensor as an electronic level indicator, but we've got a way to do that with pressure. So Andy, I'd like you to share about this project with us.
Yeah, absolutely. So again, this kind of points back to having one control system managing all of the water on the site, the hydraulics, water going into the tank, water coming out of the tank, water going to irrigation, level in the tank. So what you're looking at here on the top left, you'll see the base station 3200 controller. And then this particular cistern actually has 3 water sources that feed the cistern. We've simplified this for the purpose of today. So the next slide that Dan's going to move to shows an example of how this was set up, but it's only going to use 2 water sources so that you can kind of better comprehend what we're doing here. So that's a real world picture from a site where the base station controller is managing all the water going in and out of the cistern. So I think, Dan, you can jump to the next. So what we have here, this may look a little confusing at first, so just give it a minute and to set in, review it. What we have is a tank. And Dan, if you'll just hover over the submersible pressure transducer right there, you can see what we've done is installed the pressure transducer, lowered it into the tank. It's submersible, so you just lower it in. You can lower it in a piece of pipe. I've heard of people doing that, or just directly. And then this pressure transducer, I believe, was a scale of 0 to 10, 0 to 10 PSI. So when it's lowered into the bottom of the tank, the 20 milliamp reading would be 10 PSI, okay, if the tank is completely full of water. And then the way the pressure transducer settings work in the controller, it's similar to a flow sensor where you can calibrate the K factor. You can have 2 inputs, your 4 milliamp and your 20 milliamp, and you can play with those settings. And what we did here is we scaled the pressure transducer settings to be 0 to 100. So in PSI terms, that's 0 PSI to 100 PSI, 100 PSI when the tank is completely full. The reason we used 100 is because we wanted to read it on a percent full scale. Now, the benefit to using one sensor at the bottom of the tank is that every level of the tank, as that water drops, we can see that in terms of pressure. So if it starts at 100, as water is drawing down, now we start to read 98.6, 94.2, 91.7, and we always know the exact level of the water in the tank, and then we can use that data point to start the fill process. So in this example here, if you notice that the irrigation system is requiring 30 gallons a minute, that's what it was designed for, and the purpose of the cistern is that the well only produces 15 gallons a minute. So if the irrigation is running at full capacity, it will draw more water out of the tank than can be replenished. So the tank is kept at a full level in order to provide that reservoir of water. And then as the irrigation system is running, the tank starts to draw down. And then the way this was set up is when it hits 90% full, well number 1 turns on and starts to fill the tank at the same time that the irrigation system is running. And if the irrigation system was only running 10 gallons a minute, the tank would start to fill up. And when it gets back to 100, it would turn off. If the demands of the irrigation system continue to outpace well number 1, and the tank continues to draw down, when it hits 65%, then the city water is activated to make sure that the water going into the tank is more than the water going to the irrigation system, but it's on a priority level so that we're always using well water before the city water. And this entire setup is all managed by the 3200 controller. And it's just a beautiful thing to watch remotely because you can watch the pressure transducer, you can watch the level drop, you can literally watch it hit 90%. You can see well number 1 come on, and then you can see the water level go back up because we're reading the level in that tank. It's pretty amazing, and it's only done with that one simple device.
So the manager or contractor can log in and look at the level of their tank through Base Manager.
Absolutely. Yeah, and again, because we scaled it 0 to 100. So if they log in and they see the pressure, which is noted as pressure, is 72 PSI, they know the tank is 72% full of water.
So let's rewind the clock 20, 30, 40 years ago. And the only way I could think to do this without pressure or without a soil moisture sensor would be a series of mechanical float switches or something like that, or float valves rather. And mechanical valves fail.
I don't think you need to even go back as far as 20 years. I think you can go back as far as a few years.
Yeah, how about 1 year when we were using, soil moisture sensors in tanks, which is still a great way to do it. But a soil moisture sensor or any mechanical sensor basically tells you there's water or there's not water, but it doesn't tell you a scalable how much water. So if you're listening to this and you've used one of our moisture sensors in a tank, you may have put it at the bottom of the tank, and if the tank goes dry, we will pick up that dry signal and turn off irrigation. But if the water level is just above the sensor, we don't know how much water is in the tank. We just know whether it has water in it or it's empty. Very binary position, where the 4 to 20 milliamp reading gives us a variable reading across the entire level of the water in the tank.
Now, they used this different pressure transducer that they bought themselves. They could have, if there was a different, depending upon their plumbing, they may have been able to use the one included in the kit or not, but they also decided on the sensitivity, right? What was the reading on the sensor that we had versus what was available on the market. So I think it was nice to have those options.
Yeah, it works extremely well. And again, it's when you buy a base station 3200 controller, you get this capability. There's not a module, there's not a software update. It comes with the controller, it's on board. And so in this case, they were able to save a couple $1,000s by not having this capability in the PLC of the pump station, but directly in the irrigation controller. And then that gave them the remote access to it, so they can see all of the water on the site right through the interface of the controller and base manager.
Okay, cool. That's nice.
Come on, that's got to spark some questions. Somebody throw one out.
Yeah, maybe it's too nerdy. Yeah, Chris, you got any questions rolling in?
Yeah, one just came in. So the question from Robbie Mitten, could this system be used to start well pumps that fill our pond that supplies water for irrigation system?
That's a softball, because we were going to talk about that and somehow we missed, but there's a couple ways you can do it. So yes, it's possible. We should discuss how your current setup is configured, but you could put a submersible pressure transducer into the pond and provide a fill point that would activate the well at a given level to fill the pond automatically, and it can be done through the controller.
Well, thinking about pumps, I showed that example of that big giant pump station with the 10-inch output. It's going to feed more than 1,000 GPM. Let's scale way, way down. So a new pump, let's put a submersible pump in a rain catchment. Well, maybe it has a float switch and that's all it has. Well, now we can put some controls on a very simple pump. It may be brand new and it was never designed to run this way. So we could scale up, we could scale way down, we could take old stuff, and any of these will
yeah. And again, it's a 2-wire device, and so you could have this pond a mile away and have this controlled not anywhere close to the irrigation controller, because the pressure is read on the bicoder connected to the 2-wire path, which is a good reminder that we are not just turning valves on with our 2-wire. We are using it as a data communication cable to be able to perform these functions. And that's really the magic behind 2-wire, is that two-way data communication on the 2-wire path.
Mm-hmm.
Another good question from Ben Bodine. What could be, or what is a redundant backup in that tank to protect in case of a pressure sensor failure?
That's a good question.
We would have an empty condition that already exists in the 3200 that we could also measure with other devices in case it does draw all the way down to empty.
Yep. And if it fails the other way, there is an overflow on the tank. Of course, we don't want that, but there is an overflow. And I'm just assuming that there's a pump override on the controls. So if it starts to pump empty and it heats up or whatever the settings are, there's probably an override directly on the pump itself. Safety.
Yeah. Well, and I think it's good to note that we would have 8 different inputs available with these event decoders that can be used as a backup scenario also. So it's not just, one unit that we interface with. There's several options that we can interface with to facilitate the function of it and also protect it.
Nice.
Excellent. Someone wants to know the name and model number of the drop-in transducer.
I don't have it off the top of my head. There's probably a dozen different ones. It's basically, if you just Google searched a submersible pressure transducer, you'll find many, and they just have to be a 4 to 20 milliamp device, and then it's compatible.
Yeah. I mean, you could always put on your trunks and jump in the tank and find out, but the 4 to 20 milliamp is a good point, right? It's as long as it's 4 to 20.
Yep.
We can work with it.
Very cool. Awesome. All right. Don't have any other questions.
Well, there's one here about perhaps the model of the actual tank. I don't know what that is, but if that's an interest, I can find that out too. If this was a specific tank, the question was pressurized tank used in the example.
That your tank actually wasn't closed,
not pressurized,
not in a true pressurized, only on feet ahead pressurization. So that's actually kind of an interesting concept, right? If you were thinking of a true pressure vessel, we're going to be recording higher pressure in there. So, but this is not a pressurized vessel.
Yeah, this is gravity, water on gravity. So it's like 2.33 pounds per foot. So that's what the pressure transducer is reading, right? Or something like that.
And how tall is that tank?
That's a good question.
5 feet,
it may have been 8 foot deep, I think.
So that's not, so we're talking a very nominal pressure differential from the bottom to the top.
Right. And that's why they chose the pressure sensor with the 0 to 10 PSI, because there wasn't going to be a lot of PSI. In other words, if you're going to lower that pressure transducer 50 feet down into a pond, it would read a much higher pressure than just being 6 or 8 feet down.
Right. This is from my first irrigation class, how much pressure from each foot ahead or vice versa.
Idril has it 0.433. Yeah, there it is.
Yeah. I was going to correct you too.
What's 2.3? Is that?
Come on.
I don't know.
Round up, round down, whatever. My irrigation instructor's spinning.
All right.
Okay.
Very good. Excellent. So what's on tap for next week? We're almost at our time limit.
Okay, cool. Next week, we're going to talk about grounding, and then specifically, we're going to look at a 3-point ground test. So testing 2-wire system for grounding. I always thought that grounding was only important on 2-wire and only important in Florida. Was I wrong?
Definitely.
Yeah, and the neat thing about this is it is interesting if you ask around and you talk to distributors and you talk to contractors. Very few people have used a 3-point ground test system. Very few people know how it actually works, and it's actually not very complicated. It's just something that we don't get involved with very often, and so we thought it would be just a good refresher and something to point out where you can do this and you can actually charge a service to test grounding. And
and it's also required in order to apply for our 10-year warranty on our equipment installed. So good information to know and have in your arsenal. So join us next week for another exciting episode of Tech Talk Tuesday.
Okay. Cool. Awesome. Thanks everyone for joining. We'll see you next week with our grounding equipment.
All right.
Very good.
See you all next week.
Everybody.
Take care. Bye.
Bye.